Hello, we are discussing about GATE 2013 ECE paper. Look at the state diagram of a system given, and it shows that one x dot is equal to ax plus bu and y is equal to cx plus du. And what will be the exact equation, that is what is our matrix for a, b, c, d values for the state diagram shown, that we are going to find as a first part of this question. It's a statement linked with answer. Statement for linked answer question, so that the next one is also linking with the same problem. So now if you are going to check about this one, this is 1 by s. So let us assume if you have x of t whose Laplace transform is x of s, then what will be the Laplace transform of integration of x of t? Integration of x of t is nothing but 1 by s times of x of s. So simply 1 by s is nothing but equal to integration. Otherwise, simply if it is dx of t by dt, then this is treated as s into x of s. So x of t, x of s, d by dt is nothing but equal to s. If you are getting s in the equation, that is equal to differentiation, and if you are getting 1 by s, that is nothing but integrator. So this 1 by s means integrator, okay, or integration is performing. Integrator, okay. So now we will have to choose the nodes. So make the nodes as, let us assume this is x1. If it is x1, okay, and you are going to get it as, this will be x1, and what can this happens? So this can be differentiation of x1. This node can be differentiation of x1, so the differentiation and integration get cancelled, so you will get x1 itself. So this node can be written as dx1 by dt, and dx1 by dt can be represented as x1 dot. Similarly, this can be treated as x2, and x2 is going to be, it is integrated, so this point you can write it as differentiation of x2. Differentiation of x2 is passing through integrator, so the differentiation and integration get cancels. Then you are going to get simple x2. So this will be treated as x2 dot. So this is the way we are naming the nodes. After naming the nodes, we are going to write x1 dot, x2 dot. From that one you can write the x equation, as well as after writing y equation you can get the y matrix related to y. Matrix related to y. Okay. Now first we will write x1 dot is equal to, x1 dot is equal to, x1 dot is equal to, this is minus 1 into x1. So you can write it as minus 1 into x1 is minus x1, where x1 value can be calculated. X1 value can be calculated by coming through, by considering the incoming arrows. So x1 can be written as u into 1, u plus, this is 1 by s times of x1 dot. 1 by s times of x1 dot. Dot x1 dot is nothing but differentiation. Integration, differentiation get cancels. So this will be x1 is equal to u plus x1 only. Okay. So minus of x1 is equal to u plus x1, that I am writing it as x1 plus u. Okay. So this is first equation. And x2 dot is equal to, x2 dot is this point. So x2 dot you will get whenever x2 is passing through this minus 1 gain. So this will be equal to minus x2, and x2 can be calculated by considering at this point, by considering the incoming arrows. So incoming arrows says that 1 into x1 dot, okay, x2 dot is equal to 1 into x1 dot is x1 dot plus 1 by s times of x2 dot. This dot is differentiation and 1 by s is integration. Both will get cancels. What you will get is x2 itself. But x1 dot is already defined. X1 dot is defined as, okay, minus x1 minus u. So you can write it as, from equation 1, x1 is nothing but minus x1 plus x2 minus u. Okay, minus x1 minus u is nothing but x1 dot. That x1 dot I am replacing, and x2 I am adding. Okay, so that you can write directly x matrix, that is A matrix. So x2 dot is equal to minus of x2 minus of x2 is minus x1 plus x2 minus u. So x2 dot is equal to x1 minus x2 plus u. This is second equation. From this 1 and 2 equations you can write it for the x dot matrix. X dot, that is nothing but x1 dot x2 dot is equal to matrix form of x1 x2 plus u matrix. So this is what general equation. Here you are going to fill the values. X1 dot is equal to minus x1 plus u. So only x1 will be present with minus sign and x2 will not appear, so 0, and this is u is appearing, so 1. So x1 dot is equal to minus 1 into x1 plus 0 into x2, that is minus x1 plus 1 into u is u. So minus x1 minus u, minus x1 minus u. Okay. And next x2 dot is x1 minus x2. So x1 into 1, x2 into minus 1. So this is 1 minus 1 and plus u. So this will be plus 1. So this is x matrix. Okay. And next y matrix. Y matrix can be written as y is equal to, incoming arrow only how to write, y is equal to 1 into x2 dash. 1 into x2 dash is x2 dash. X2 dash is already from the equation 2, you can write it as x1 minus x2 plus u. So simply y can be written as, okay, x1 x2 plus u. So this is x1 x2 is x1 minus x2. So this will be 1 and minus 1, and u is present, so you are writing it as 1. So this is C matrix and it is D matrix. This is x1 dot x2, that is nothing but x dot matrix, and it is y matrix. Now check the answer, which will be the right answer. So this answer A is going to be the right answer. Okay. Minus 1 0, 1 minus 1 and 1 minus 1 and plus u. 1 into u is nothing but u. So the right answer is A. Now from this one you can say it as A is equal to, this is A matrix and it is B matrix, this is C matrix, and D is equal to 1 directly. So A matrix is minus 1 0 1 minus 1. Okay. Now we are moving into the second one. Second question in this one is, for the same question you need to find state transition matrix e power at. State transition matrix e power at, it is also treated as pi of t. Okay, and pi of t is nothing but inverse Laplace transform of Si minus A inverse. State transition matrix defined as Laplace inverse of Si minus A inverse. So first we need to find Si minus A, then Si minus A inverse, then apply inverse Laplace transform to get e power at matrix. And we know that one A value is, where A is equal to given as, okay, just now we found A value is minus 1 0 1 minus 1. So this matrix we require. So first we will see Si minus A. Si means S into, I means identity matrix. Identity matrix order is same as that of A. Since A is 2 by 2 matrix, so identity matrix is also of 2 by 2. So 1 0 0 1 minus A is minus 1 0 1 minus 1. So this will be equal to, okay, S 0 0 S minus minus 1 0 1 minus 1. So finally Si minus A is equal to, you are going to get it as S plus 1 0 minus 1 and S plus 1. This is Si minus A. Now we need to find out Si minus A inverse. For any matrix, let us assume it's a 2 by 2 matrix A, B, C, D. If you want to find inverse, at that time you have to go for AD minus BC into D minus B minus C A. This is what the equation for the inverse of matrix. So you are following that one. AD is S plus 1 into S plus 1, which is S plus 1 whole square, minus BC, B into C is 0 into something, so it will be 0, so you no need to write that minus 0. Next, A, D are going to be interchanged so that it will be s plus 1 and this is s plus 1. Next B, C are multiplied with minus sign. Minus into 0 is 0 only. Minus into minus 1 is plus 1. So now if you are taking minus 1 by s plus 1 whole square inside, each and every element of matrix is multiplying with 1 by s plus 1 whole square. So this will become 1 by s plus 1 and it will be 0. This is 1 by s plus 1 whole square and it will be 1 by s plus 1. So pi is equal to pi of t is equal to e power at is equal to Laplace inverse of si minus a inverse. So that can be written as 1 by s plus 1 is nothing but e power minus t. Inverse Laplace transform of 1 by s plus 1 is e power minus t. 0 Laplace transform is 0. Inverse Laplace transform 1 by s plus 1 whole square is t into e power minus t and again it is e power minus t. This is what state transition matrix. So the right answer for this one is again A itself. E power minus t, 0, t into e power minus t into e power minus t. Okay. Thank you.